Good afternoon, my name's Damian Jolly. I've been a manufacturing systems specialist with Sage for 15 years. And in that time, I suppose I've worked and developed solutions for the likes of General Motors, Holden, Toyota, Electrolux, Coca-Cola, with a particular focus in the food and beverage area. I've seen a lot of changes in the manufacturing environment over this time, and it remains a really exciting place to work, albeit a changing one. And so what I'd like to do is start off just by looking, before we talk about collaborative robots, which is something completely different to what we were covering off before, is I just want to have a little sort of look back at the manufacturing sector as a whole, because collaborative robots are set to really transform the manufacturing sector in Australia particularly. So let's start by having a look where that's likely to go in the next 5 years. So it's not a stretch to say that the future prosperity of Australia's economy depends heavily still on manufacturing. As an industry, manufacturing supports millions of jobs, ensuring that Australia remains competitive in today's global marketplace. But we've been shaken since the GFC, and in fact the workforce has shrunk in that sector by 141,000 from 2008 to 2013, according to a study by AI Group. Unfortunately, much of our heavy industry has been lost in recent years, and it will continue to shrink. Smelters and car assembly are shrinking, and many of these jobs actually are lost here in Victoria. The industry is under considerable pressure as globalisation fuels competition from lower cost countries. High input costs and low complex local demand also add to the burden. Ever-increasing levels of automation and industrial internet and newer methods of production, with those tools we're on the cusp of reshaping Australian manufacturing. And to survive, we need to invest time and effort into looking at opportunities to be as agile and as efficient as we can. With the exception of large-scale manufacturing, which are becoming fewer and fewer, our manufacturing sector has some key traits. These are traits that are fairly unique to Australia. We're seeing more and more short-run capability being built into our manufacturing sector, producing a broader range of products to suit the Australian palate. It's rare these days to see a manufacturing line produce only one product. So this means that more changeovers, which is a burden on productivity, it typically represents one of the largest opportunities for improvement in the manufacturing sector. I think it's relevant to today's conversations around standards, is that there's becoming an increased burden for the requirement for safety in things like ingredient and product traceability. This means complex systems with a focus on increased data capture and reporting. And often this data is required in real time. But Australia has a highly skilled workforce, and we have a number of artisan-style manufacturers, and that sector is actually growing, supported by good levels of skill. Interestingly, it's small business that are the largest employer in the food and beverage sector, and this workforce is becoming more technically savvy as we get used to things like iPads and Android devices. And we still have a larger number of repetitive tasks though, and these tasks are ones that Australian workers don't really want to do. As I mentioned, we're information hungry and we're rapidly adopting technology that continues to create large quantities of data, right down to minute details. And this information is enabling us to make more with less and reach new levels of efficiency and connect shop floor with the broader enterprise to make better decisions. These trends are set to continue, and it's great news for Australia. And there's some quite remarkable technology that's coming on board as well. What I'm talking about is collaborative robots. That's what we all want to talk about, is robots. But before we talk about robots and how to identify opportunities to use them within your workplace, I'm just going to take a little bit of a look at some of this territory. So what are collaborative robots? Well, let's start by examining traditional robots. The link between automation and productivity is an obvious one, and it helps explain why China, with its rising wages, is investing so heavily in industrial robots right now. But not every business can budget and plan for a whole lot of money and time to spend on integration if they decide they may want to invest in automation. Traditional manufacturing robot solutions are tried and tested. They're fast and efficient, and they can do many things that humans can't. Characteristically, though, as we can see by this picture, they're surrounded by large fences and safety zones. A collaborative robot presents a very different characteristics. They're typically compact and lightweight, and they're dexterous. Their appearance is designed to encourage human interactions. They often have soothing colours and round shapes, and some even have animated faces, features that are designed to encourage a human-machine interaction. Changes to the robot interfaces and software allow a diverse range of tasks to be automated by people without actual robotics experience. The flexibility of robots that can be relocated within a plant very quickly and quickly retrained to do a different task is also suited to some of the smaller manufacturers who are doing low mix, high volume, or low volume, high mix goods. Collaborative robots have some other names as well, so interactive robots, and the one that I like is cobots. They'll certainly be a disrupting factor in our manufacturing industries. Although robots are regularly associated with replacing human workers, in reality, collaborative robots will more likely support manufacturing taking place in more locations, closer to where those products are consumed and reducing supply chain. They may even ultimately support the creation of local jobs. So collaborative robots have different speeds and payload specifications to traditional robots. And this is the part of the reason why they're considered safe to work alongside humans uncaged. I feel a little underqualified to talk about safety in this particular forum, but I can share some of our experiences around safety in cobots later. They're programmed differently to a traditional robot as well, being trained by expert users rather than being programmed by a technician. And operators in this example, you can see, is physically grabbing the robot to train a task versus the traditional programming via a pendant. The software interfaces are also improving in line with typical software developments. There's even some open source software for robots called ROS, which stands for the Robotic Operation System. And this is an open source and flexible framework for writing robotic software. It's a collection of tools and libraries and disciplines, and it can be used across multiple platforms, which reduces the time and effort taken to program a robot. At least two of the collaborative robots that I've seen on the market today, as I'll say the word he, has an animated face which will turn in response to an operator's interaction. The robot will nod and indicate an instruction has been learned or frowned when something has gone wrong. The animated face allows the robot to more closely mimic typical human behaviour, and it encourages people to interact with those robots, as we all distinct and natively understand how to relate to someone's face. When you see a robot frowning or smiling, you sort of understand what it's trying to do as well. I just want to make a comment about this too. I think this is actually very significant. When I saw the collaborative robot that I'm mentioning here, I thought it was a bit of a joke when I saw that it had a face that smiled. But then when I realised that it broke down barriers, and when I saw how operators interfaced with the robot and how they reacted to it and understood very clearly when something was going wrong, I actually changed my mind and thought, you know what, there's something behind this. This is a step change in the way we interface with robots, and it's only going to increase and improve and change. I guess the big question is, are they safe? Well, they use integrated sensors which can feel external forces. One of the robots, which I don't show here, has a skin that can detect when it's pressed, very much like our skin, and it can then either slow or stop its movement. They use proximity sensors, sometimes ultrasonic, that can detect when a human or object enters the robot's workspace. So they have passive compliance, and if an external force acts on a joint, this joint will submit itself to that force. And so in the case of a collision, the joint will move in the opposite direction to avoid injury. So the robot manufacturers claim their robots to be safe according to safety requirements stipulated by the ISO standard 10218. Does anyone know that standard, by the way? Great, okay. I'm only vaguely aware of it. But even if assuming this robot is safe, and the situational risk assessment is still required to make sure that that specific application is safe. If you're giving your robot a bunch of knives, you probably will fail the, the situational safety assessment. So let's have a look at what's on the market. Not all collaborative robots are the same. like any product market space, the different robots have different capabilities, strengths and weaknesses. And here are some examples of the robots. This one here is called Baxter by Rethink Robotics. So you'll notice straight away that Baxter has a 2.5 kilogram capacity per arm. That's significantly less than the average industrial robot that we see out there. Although it is a 7-axis arm, so it's quite a flexible arm. His accuracy is, he's accurate to within about 0.5 mil. That's not particularly accurate in terms of robotic standards. But you'll also notice that he has wheels and is able to be moved around, which is significant. In particular, this robot is quite affordable and he has a vision system built into each arm, so he can actually also do vision systems integrated into that as well. This is Sawyer, son of Baxter. You'll notice that it's a different payload, so he has a stronger arm, and in fact they've made some changes to this arm in terms of its mechanical build so that it's actually improving its accuracy. This arm has a longer reach and it's more suited to machine tending. This is also what we call a benchtop robot, so it's less mobile, but all the same it can be deployed fairly quickly. This is a popular brand, the Universal robots, UR3, 5 and 10. I suppose these robots most closely mimic what we know and understand traditional industrial robots to be. However, this one also has the safety ratings that make it safe to work alongside humans. A big part of that is the reduced payload, but it's also the ability to stop when it detects a collision. This is also a benchtop mounted robot. Yumi by ABB. Now the most significant thing that we'll notice here is that it has a very small payload, but it's extremely accurate, so we'll see the accuracy is improved. Again, it's programmed, rather than programming in a traditional robotic sense, it's programmed by showing and then fine-tuning. It's also a desktop robot. And this one in particular is suited to very small parts assembly. This robot is capable of doing very dexterous tasks and very precise tasks that the robots I've shown so far are not capable of doing. And then finally we talk about the IIWA. This robot has the highest payload. You'll see there it's 14 kilograms. But it also has a very high level of, or high performance collision detection. And they show on the video when they're on the demo, if this robot collides with a glass of water, it just stops instantly. So it's not as fast, but it's very accurate and it has this very high level of collision detection. So these are some of the collaborative robots, and it's an emerging field. Examples of processes for adopting this type of technology are still few and far between. And through our experience with integrating Baxter, which I'll tell you about, we learned a lot of lessons about how to approach possible applications, and I'm going to talk to those now. Rather than being strictly a technical process, we used our experts from Sage Business Optimization and Sage Training to engage with the management, the technicians and the operators in a way that would enable them to understand the robot's value and identify possible uses. We started by training them in our Sage training facility, and because collaborative robots can be moved and retrained and redeployed quickly, opportunities open up more frequently than you might think, and you need to be really open to that. And it's really hard to explain, but you really have to approach collaborative robots collaboratively. Often it was the operators and the non-technical stakeholders who had the best ideas and saw new opportunities for the use of the collaborative robot. You need to really adopt a traditional continuous improvement approach when using the robots. This was really the second key to unlocking the value. Understanding the current situation and identifying barriers to flow and value. And this is a process that many operators and stakeholders really understood and were familiar with. And so then a collaborative robot is just an additional piece in the continuous improvement solution toolbox. So I'm painting the picture here of a very flexible tool that can be easily redeployed and reused in various areas of your plant. And that's something that you just wouldn't consider with a traditional robot. And I think this highlights a really key point in the difference between collaborative robots. And then of course experimentation was important. So prototyping is the next step in the approach, and being able to play with the robot in a safe, non-productive environment. As you can see from the images, the collaborative team did a lot of experiments and trials, and these especially helped to communicate progress to stakeholders in a new field such as management and project sponsors. But like all robots, it's all about the grippers. So, or more correctly termed, the end effectors. So most of the cobots on the market today come with a wide range of grippers and sucker options. So be prepared to experiment with those and customise where necessary. The mechanical engineers at Sage were particularly useful at designing and specifying the specialist end effectors that we needed to support particular applications as we thought of them. But we're engineers nonetheless, so at the end of the day, you still need to sort of take a very structured approach to collaborative robots because they need to be reliable and safe in a productive environment. So the robots may need automation connections to move materials or interface with other systems. You need a good understanding of cycle times, throughput, physical space limitations and power requirements. These are all an important part of the process. But I think it's important just to really remember that you need to be open as collaborative robots. They can be quickly redeployed into different applications. And it really is part of the continuous improvement team's role to be able to think of the collaborative robot as part of their toolbox and say, hey, let's go and get the robot and see if we can apply that in this situation. So I'll talk about a case study with Haig's Chocolates. Haig's is a South Australian brand. It's an iconic family-owned artisan chocolate manufacturer that's been celebrating its 100th year in operation this year. They're well known for their factory tours, which see about 30,000 people visit their production facility annually, and they produce over 250 different products, most of them by hand. They engaged Sage in 2014 to integrate a Baxter into their operation, having secured a government grant for new technology. For such a historic manufacturer, they're certainly looking ahead. And with so many products and processes within their business, there was no shortage of suggestion from the operators. We worked closely with the stakeholders, spending time observing their processes and consulting with their line workers, trialling different solutions at our training facility. Interestingly, when challenged on the idea that Baxter would replace jobs, the managing director of Haig's, Alastair Haig, pictured here in the centre next to the minister and the Sage CEO, stated that it's the tasks that we're considering for Baxter are the mundane ones that no one really wants to do. And so the operators were very, very forthcoming in suggesting tasks that they wanted Baxter to do that they didn't want to do. So as I mentioned in our process, we started by training the stakeholders, and that wasn't really plainly obvious to us at first. We started by limiting this to the technical project team, but we soon discovered that it was the operators as well as the management that needed to understand what Baxter could do and how it could be used. During this training, we learned many things about Baxter's strengths and weaknesses. In particular, the way you set up and position Baxter was very important. He has a Goldilocks zone, which is really in front of him where he can do some really great tasks. But if you set stuff up that's too far away, he becomes less accurate and less repeatable. But he also was able to do things that we didn't expect and do things that operators can't do, and that was maybe do a task in front of him while simultaneously reaching behind him to pick something up. So it was once we understood these limitations, capabilities and strengths that operators started to suggest tasks that he could do and that he would be good at. Enter the truffle. Ultimately, we settled on his first task, which was to automate the cooling and packing of truffles. Chocolatiers would place the completed truffles, which they made by hand, on a conveyor belt after they'd dipped them. And this would take the truffles through a cooling tunnel to set them. And once set, Baxter would pack them, ready for shipment. The justification for the task came from the continuous improvement team. The existing process is a batching one, that required the chocolatiers to make truffles into trays that then had to be racked and stored while they dried. At the end of the day and at the end of each shift, they would spend 2 hours repacking the dried truffles into boxes. This is expensive and it had double handling, and it was also disrupting throughput. It was a mundane and boring task, and it was one that was not liked by the operators. So the Baxter solution would increase throughput as well as reduce costs and reduce space. So next we trialled the process at the training facility, which I'll get this going afterwards. And what you'll see there is that you'll see a video of Baxter picking up truffles with his grippers and then putting them into a tray. And although those truffles were made all year round, and that's Baxter's first task, this is not destined to be his life of just packing truffles. There's also a raft of other opportunities that presented themselves, and a popular one was this: Easter eggs. So Easter's a busy time for Haigs. In fact, Mother's Day and Easter are their two busiest times. And another task that Baxter could excel at was actually picking up and weighing each Easter egg, which is a task that has to be done by every egg. Again, this task is not relished by the chocolatiers and is one that does not justify a permanent automation solution. Baxter can pick up the eggs from a known location and place them on the scale. We can configure feedback from that scale via a serial interface or even by Modbus. And then using that signal, Baxter can accept or reject the egg, and the accepted eggs are packed into a box ready for dispatch. So this is probably a good time to highlight the ability to move Baxter. What you're seeing here is a 2D barcode, and we call it a landmark. And this is permanently fixed in the factory at a known location. And then when it's time to move Baxter back to a known task, you position him in place using the camera system in his arm. He reads the 2D barcode, and at that point he's able to recall a previously trained task, as well as make the minute adjustment offsets for his slight change in location if you haven't put him back exactly in the same place. So we learned a lot when we were putting in Baxter at Haigs. And in fact, given there's a lot of hype around cobots or collaborative robots, it becomes really difficult to understand whether these robots are going to be useful in manufacturing or not. And I would certainly say that they are. And some of the things that we learned is that you really do still need to approach it with a standard continuous improvement engineering discipline and fully understand what your needs are. But you need to consider collaborative solutions with a really open mind, because, as I said, often it was operators that suggested an activity for Baxter or for the collaborative robot rather than the engineers. You have to be realistic about their capabilities and their limitations. I guess one of the things I haven't said is that collaborative robots typically move a lot slower than a traditional industrial robot. So cycle time's a really important factor to consider. And then finally, I would say don't go it alone and seek some support from an expert.